Guys, I'm Dave, and today we're going to talk about what I know about thunderstorms and tornadoes. So, starting this off, we'll just look at a picture right here. So this is a thunderstorm, one that I made up on paint.net. And coming back here, we have land, and then in this thunderstorm, we have two different speeds of wind moving over each other. Now, in this case, I put this one and this one going the same direction. However, the top one is moving faster than the bottom one. Conversely, this could also occur if this lower one was facing this way and they were going against each other. But either way, that's going to cause this to get pushed over the top of this one, causing a rotation in the atmosphere. Have these two different wind speeds, which will eventually develop into what is called a mesocyclone. It's a cylinder of air moving by convection through the atmosphere, getting pushed along by the thunderstorm. So there. Now, if the conditions are right, and this air mass moving through the thunderstorm reaches an area of hot land, it's going to encounter what's called an updraft, which is just heat rising from hotter land relatively to the storm and where it's coming from. What that is going to cause is the mesocyclone to move over it, and as it's pushed up, it's warped into a semi-donut shape like so. Now, when talking about these large thunderstorms, it's typical for there to be hail, and that is because as all the water and precipitation within the storm is pushed up by this updraft, it reaches an area of higher elevation, which is colder and will cause the condensation to freeze, which normally, if not strong enough, will melt before it hits the ground. But if strong enough, as is typical in these types of storms, it will be bounced up because the updraft is stronger than gravity, and that will cause hail to form. So hail is traditionally proportional in size to the strength of the updraft, which is also proportional in size to the strength of the storm. Alright, so as that's occurring in the northern hemisphere, the counterclockwise rotating side of the donut, which in this case would be this, because this is all still rotating this way. So as it comes down, it would be rotating like that. It's going to strengthen, which will be shown on radar as a rotation like that, which could eventually develop into a hook echo, which is traditionally when they would put out a tornado warning, even if there's no reports of tornado on the ground, this is showing that it is either on the ground or very imminent to being on the ground. Now in this drawing I put it going clockwise, which is incorrect for the 3D model, but just imagine it going this way, it's the same thing. So back to the 3D model. If this mesocyclone, this side of it, touches down, that would result in a tornado. Now conversely, looking at it the other way, if this side touches ground, it's also a tornado, and it would look like this. It would be a anticyclonic, but they're typically rare in the northern hemisphere. If you're in the southern hemisphere and you had one, it would be clockwise generally. Other than that, it's about all I know. So if anyone wants any more resources or has any suggestions for more information on this, just leave a comment.